All right, let's take a look at our lesson 2 lecture today. So lesson 2 obviously you know is all about vectors. We call it vectors point the way. So go ahead and pause the video, make sure you have the lecture notes ready, and come back when you're ready to go. All right, some vector basics. A lot of things you probably already learned, and especially if you've taken a physics class, but definitely need to make sure you understand all this stuff. Vectors have both magnitude and direction. And to find the magnitude, which is also the length of the vector, we can calculate this, the square root of v dot v. So that's a dot product between the vector and itself, and that's the square root of that. Okay, so dot product in 3 dimensions of two vectors, two three-dimensional vectors. So if I want to do x dot v, it's the same as 2 dimensions, except we just add that third dimension on. So it's x1, y1 plus x2, y2 plus x3, y3. Okay, geometrically, you might have learned this before in your physics class or pre-calc class. X dot y is equal to the magnitude of x times the magnitude of y times cosine of some angle b. Okay, so geometrically, what does all that represent? Well, x, we know that is just your x magnitude. Y is your y magnitude. And then b is the angle between x and y. Okay, so this basically tells us that if the dot product is positive, well, that means that cosine b must be positive, which means the angle must be between 0 and pi over 2. If the dot product is 0, that tells us that cosine b must be 0, and that tells us that the angle must be a right angle. And if the dot product is negative, that tells us that cosine b must be negative, and therefore b must be between pi over 2 and pi. All right, given a triangle between 3 points, how do you determine whether the triangle is a right triangle or not? Basically, I mean, obviously there's a lot of ways to do this mathematically, but in this lesson, using vectors, what you want to do, it's a simple 2-step process here. You want to make some vectors. And basically what you want to do is you want to make vectors, you just subtract 2 points. So if I give you 3 points, you take 2 and you subtract 2 points to make a vector, and then you do it again to make another vector that meet at one of the points. And then you'll calculate the dot products. Now, if you do one dot product and you get 90, obviously you can stop there. You don't need to keep checking all 3. Or if you get an obtuse angle as well, you can stop there because then it can't be right. But if you do the first dot product and you get an acute angle, then you have to keep going, try another one to see if you get any more right angles. All right, page 2, we're talking about lines now. To write a parametric equation of a line, this is the general formula you will use. L of t, we'll call it, you pick 1 point on the line, so one of the 2 points given to you, plus t, and you multiply that by the vector 0.1 minus 0.2. Or 0.2 minus 0.1, doesn't matter. So which part of the equation determines the direction of the line? So which direction will be moving as t increases or decreases? That'd be that. So depending on which point you pick first, the second, and then if you whatever vector you get back, as you put t in, that'll tell you what direction of the line is moving. How can you write the equation of a line parallel to the given line? Well, that's really easy. Just pick a third point. So we'll call it point 3, and make sure point 3 is not on the line. So that says point 3 not on L of t. Sorry about my bad handwriting. And we'll call this line P of t for parallel. And you do point 3 plus all this. How can you write an equation of a line perpendicular to that line? Well, you can first just kind of think your way through it and find a perpendicular vector. Make sure that's a perpendicular vector by showing the dot product is 0 with your direction vector. And then use any point on the line. With the new vector. All right, so let's take a look at an example, a two-dimensional example here. So it says, given point 1 and point 2, find the equation on a line. So the first thing I'm going to do is find the vector, direction vector. Again, it doesn't really matter if you do point 1 minus point 2 or point 2 minus point 1. So I'm going to do point 2 minus point 1. So it would be 0 minus 3, 7 minus 2. All right, we'll call our vector then negative 3, 5. Sorry about my bad squiggles here. Okay, and then just pick a point. So let's use 3, 2. So my equation would be 3, 2 plus t negative 3, 5. Or you could separate it into two separate equations. X of t equals 3 minus 3t. Y of t equals 2 plus 5t. That would be fine. Okay, so a line parallel to that line, well, that's easy to do. Just make any point that is not on that line. So since 3, 2 is on that line, I'm going to guess 3, 3 is not on that line because this is not just a vertical line. So we'll use 3, 3. Plus t negative 3, 5. And again, you could write that as two separate equations. X of t equals 3 minus 3t. Y of t equals 3 plus 5t. All right, now a line perpendicular to the given line. Remember, if this is our direction vector, all we need to do is come up with a vector that's perpendicular to that. How about, let's call it W. How about 5, 3? All right, so show that those are perpendicular by doing a quick dot product. So v dot w, we have 5 times negative 3 plus 3 times 5, which is 0. So that's good. That means that that vector is perpendicular. All right, and then just use a point on that line. So let's call this line, let's call it R of t. Not really sure why I picked R. So then the vector would be, pick a point on the line first. I'll just use 3, 2 since I know that point's on a line. You could also use 0, 7 or any point on that line. Plus t, 5, 3. And again, you could separate that into two separate x of t, y of t equations if you'd like. All right, components. You might have learned components as something else in your physics class. What we call them in this class is push along. So components are introduced as what we call push along. To find v push along w, what we do is v dot w divided by w dot w and multiply that by the vector w. It represents the component of v in the direction of w. V push along w is also the multiple of w whose tip is closest to v's tip. So you can see that in the picture over here. The blue one is v, the red one is w, the green one is the push along. So the tip of the push along is the closest point on w to the tip of v. And because of that, since the shortest distance from a point to a line is perpendicular distance, we can be sure that the following three vectors will always form a right triangle. The vector v, the vector v push along w, and the vector that connects those tips. How do you know if the push along is with y or against y? This is very easy. If the dot product is greater than 0, it's with, I should be using x and y, huh? So if x dot y is greater than 0, it's with. If x dot y is less than 0, it's against. All right, so another two-dimensional example here. Find the push a vector along y, vector x along y. So to do that, we are going to do x dot y over y dot y times the vector y. Okay, so x dot y would be 4 times 6 plus negative 2 times 1. Y dot y would be 6 times 6 plus 1 times 1, all times the vector y. And just simplifying that, let's see, we get 22 over 37 times the vector y. So that would be 22 37s times 6. And then times 1. So that vector right there is x push along y. If you want to do y push along x, there's the expression for that. We already know x dot y is 22. X dot x is 16 plus 4. We can reduce that to 11 tenths, and multiplying that by vector x, we would get 44 tenths negative 22 tenths. And we can reduce that to 22 fifths negative 11 fifths. So that would be the vector y push along x. All right, the last thing here, given position, how do you find the velocity, acceleration, and speed? So let's call our p of t function position. Velocity, remember from your calculus 1 course, is just a derivative. And acceleration is the derivative of velocity, or the second derivative of position. And then finally, speed. Speed is just the magnitude of velocity. Okay, and obviously you can write that out like this if you want to as well. So p prime of t dot p prime of t. That's another way you'll see that in this chapter. Okay, the rest of the page is just some helpful hints for you to work through as you work through your try-its. Make sure you read through those. If you have any questions, ask. Otherwise, I'll see you in class next time.